Hello everyone, today in this video clip I'm going to go over more trig identities for you guys. We're going to continue from last time. We talked about the sums or difference of cosine trig function already. So today I'm going to start with the sum or difference of sine and tangent function. So let's start with sine. We have sine of the angle A plus B is going to be equal to sine A cosine B plus sine B cosine A. Okay, so sine of sum of two angles A plus B is sine A cosine B, and then you change the angle for the sine cosine, sine B cosine A. Alright, and sine of A minus B, all you have to do is change from plus sign to minus sign. Very much same. Sine A cosine B minus sine B cosine A. Right? Example. If they ask you to calculate, how about sine of 75 degree? I use degree, but you can think of radians, the same thing. And we don't have any formula on top of that for 75 degree, but you can break it out as sine of 45 degree plus 30 degree. And now apply the formula, adding, so it's going to be sine 45 times cosine 30 plus sine 30 times cosine 45. And you know the sine of 30 45 is root 2 over 2. Cosine of 30 degree is root 3 over 2. Plus sine of 30 is root 3 over 2. Cosine 45, hang on, cosine of 30 degree, yeah, and sine of 30 degree, yeah, and then cosine of 45 degree root 2 over 2, I think. Check if I got anything wrong. Yeah, cosine of 30 degree is root 3 over 2, right, and sine of 30 degree, yeah. And then you simplify. Okay. I still feel like something wrong in here. Let's see. Sine of 45 degree cosine of 30 degree plus sine of 30 degree cosine of 45 degree. Is that right? Yeah. And sine of 45 degree is a root 2 over 2. Yeah. Cosine of 30 degree. Cosine of 30 degree. Right here. Yeah. Root 3 over 2. Yeah. Sine of 30 degree. It's 1/2 right here, no wonder. Yes, 1/2. Now, I figure out the mistake. So this is square root of 6 over 4 plus root 2 over 4. And so this is root 6 plus root 2 over 4. Pretty much. Or you have a problem, a typical problem, just like the sine equation before. They give you sine A and then they give you cosine A. You have to calculate sine B and cosine B. I would refer you to go back to the previous video clip and look at the examples. It's exactly the same. Okay, let's move on to tangent. Tangents of A plus B is equal to tangent A plus tangent B over 1 minus tangent A times tangent B. And similarly, if you have tangent of A minus B, it's going to be tangent A minus tangent B over 1 plus tangent A tangent B. Because they have a formula for cotangent as well, what our textbook didn't include for you. And that means that you don't have to worry about it, so you don't have to run down. That is the sum of difference of sine and tangent, in addition to the sum of difference of cosine that we learned before. And I claim that the type of exercise is going to be very similar. Let me look at the example, one more example on here, then I'm going to move on. Oh, how about this one? Verify the identity. Okay, I see this example. They ask you to show that tangents of x minus y. I'm just randomly looking at an example. Minus tangent of y minus x equal to 2 tangent of x minus tangent of y over 2 tangent of x minus tangent of y over 1 plus times x times y. I think this is pretty easy. The right hand side, this is this formula right here. The right hand side, this is really 2 times tangents of y, x minus y. Right? Think of x as a and y as b. I have this. So the whole thing right here is just tangent of x minus y. So this is tangent of x minus y. And then tangent of y minus x, opposite, right? Since tangent is an odd function, so tangent of y minus x, we write the tangents of negative a is equal to negative tangents of a. This is the odd function. That's what we went before. Alright, so we have tangents of a with a negative sign is going to be equal to tangent of negative a. So if I think of this is negative tangent of a right here, it's going to be tangent of the opposite. So this is going to be tangents of x minus y. This is like a, and this is like negative a plus. So it's tangent of x minus y plus another tangent of x minus y. This is one way. I think this is the fastest way. Okay? If you don't see it, you can start from the left hand side using the somewhat different of 2 angles. You can have the same answer. Let me show you another way. This is faster. Alright. You can start from here. Use a formula. Tangent of x minus y is tangent of x minus tangent of y over 1 plus tangent of x times tangent of y. And subtract tangent of y minus x is tangent of y minus tangent of x over 1 plus tangent of x times tangent of y. Now you combine the 2 fractions together. So the same denominator, 1 plus tangent of x, tangent of y. What do we have on the top, on the numerator? Tangent of x minus tangent of y. Now be careful, right? You got a minus sign. Minus what? I've got to distribute a negative to the 2 terms. So let me write 2 lines. Minus the whole thing in parentheses. Tangent of y minus tangent of x. Right, I wrote it in parentheses. Now you guys gotta distribute a negative sign into the 2 terms. Minus tangent y and then plus tangent x. And then you see what you have in here, tangent x. Combine the like term, that means 10x plus 10x is 2 times tangent of x. Minus 10y minus 10y is minus 2 times tangent of y over 1 plus tangent x times y. You have the answer. It's just a bit longer, but it's going to get you guys to the same answer. But it's easy to see, I think. So another type you see it right here, pretty much the same as the previous one on the previous video. I mean, this is what show you the identity, and they and they ask you to verify if the left hand side is equal to the right hand side. Okay, let me move on to more trig identities. Now we talk about something called double angle formula. So double angle means this. You see something like this. Sine of 2a. 2a at the angle. Okay, so say whatever a, say a is 30, 2a means 60. If a is 40, and 2a is 80. Okay, sine of 2a is equal to 2 times sine a cosine a. Cosine of 2a is equal to cosine square of a minus sine square of a is also equal to 2 times cosine square of a minus 1, and it's also equal to 1 minus 2 sine square of A. Be careful that those formulas are very, very popular when you guys get to calculus, because you guys are going to use them quite often. And the problem is this: when you have an integral problem, you see an angle of A and an angle of 2A's mixed together, you try to bring it back to the same angle of A, and this formula will help. More. How about tangent? Tangent of 2A is equal to 2 tangent of A over 1 minus tangent square of A. Okay. All the formulas right here come from the sum of two angles. You think of sine of 2A as what? Sine of A plus A. Okay, I'm trying to prove the formula for you. Alright, and then apply the formula you learned before. Sine A, cosine A. Sine A, cosine A, and then plus another sine A, cosine A. As we learned before, simplify, you have the answer. And same thing for cosine of 2A. And you know that sine square plus cosine square equal to 1. So cosine A square minus sine A square, and you know that cosine square is cosine square is 1 minus sine square. You plug in, you have here, and you know that sine square negative sine square is cosine square minus 1. You replace it, isn't it? You plug it in, you have the second equation. So with the cosine of double angle, cosine of 2A, you have three different identities. It depends on the type of problem. You may use one of those three. Okay, that's the double angle formula, and I strongly encourage you guys to practice some number of exercises, then you get the hang of it. Let me move on. The next type is called the half angle formula. Say you have the angle, it's actually the same thing in here, they just write backward. Alright, so sine of A is equal to square root of 1 minus cosine of 2A over 2 with plus or minus. You guys see where I got this formula from? This one is coming from this one right here. Let's see. Oh, right here. I'm sorry. Was that right? Let me see. Over 2 sine. So, oh, right here. Cosine of 2A is equal to 1 minus 2 sine square of A, right? So what did I do? Bring the cosine 2 sine square A in here minus cosine of 2A. So 2 sine square of A equal to 1 minus cosine of 2A, and I take square root, so I got a plus or minus sign in front. And what does it mean by the plus or minus sign in here? That means that if the angle A is in the first quadrant number 1, then it's going to be plus, right? Angle A is on the quadrant number 2, it's going to be minus. Or quadrant number sine A is number 1 plus, 2 plus, I'm sorry. Sine A is quadrant number 3, and quadrant number 4 is going to be minus. And of course, same thing for the other. Cosine of A is equal to, I'm using this one right here. Cosine of A is what? Square root of cosine 2A minus 1. So over 2 plus or minus. Alright. And then the last one is tension. Let me double check on the formula, see if I got it right. Go inside of A, 2A, this one. How do I get this one? Up at 1 on both sides. Right. It's not really the new formula, it's just come from here, and then you rewrite it on the other side. Instead of cosine of 2A equal to something, then you write it the other way around. Sine of A, you solve a sine in terms of cosine of 2A. is you solve a cosine in terms of cosine of 2a. Okay. All right. And then for tangent, now it's a new one. Okay. But before we move on to tangent, let me rewrite the formula in terms of the style or the way that our textbook write. So sine A equal to plus or minus 1 minus cosine of 2a over 2, right? So you have what? Sine of, example, 30 degree is equal to what? Plus or minus square root of 1 minus cosine of 60 degree over 2. You see? If I think of A at 30 degree, then cosine is 60 degree, so forth and so on, any angle. Instead of writing A and 2a on that side, this is how our book write, and I claim it's the same thing. If you think of the 2a as an angle, say an angle B, then this is going to be B over 2. So sine of B over 2 equals 1 minus cosine of B over 2. That's, they call it what? Half angle formula. And the reason why I wrote it in the previous form, because I tried to link the second type. This is actually in section 5.5. It's really coming from the previous section 5.4, nothing new. And similarly, instead of writing 2a right here, and if you think of it as the angle B, 2a as B, and this angle A right here is a half angle. And we call it what? Half angle formula. It is really the double angle formula. Okay. Now we talk about tangent. So tangent of B over 2 is equal to, now you guys gonna have like 3 formulas. Sine B over 1 plus cosine B is also equal to 1 minus cosine B over sine A, sine B I mean. And then it's also equal to plus or minus square root of 1 minus cosine B over 1 plus cosine B. Either one of those 3 will work. Okay. And how do you get this formula? Tangents of B over 2, you can think of a tangent is tangent is what? Sine over cosine. So you plug it in, sine right here over cosine right there, right? And then you simplify, you have the formula. Okay? Alright, and this is, I think this is the end of 5.5. Let me look at the example. Just give you 1 or 2 examples in this section. And then I'll move on. Let me just think of one, make it easy. Now that you got the half angle formulas, you can calculate something like, for example, what is sine of 15 degree? I can use this formula right here. 15 degree is equal to square root plus or minus in front 1 minus cosine of 30 degree over 2. You guys see what I'm doing right here? I think of 15 degree as a half angle. Well, in my opinion, I would put to section 5.4 and 5.5 at once, but they separated to make it shorter for you guys, so I'll try to go with the book. Alright? And then you know about cosine of 30 degree, plug into the formula, and by the way, 15 degrees on quadrant number 1, so I know the sine is going to be a positive number. Okay? What if you got something like 200 degrees, for example, it's going to be a negative, right? This is positive now. Don't need that. So this is square root of 1 minus cosine of 30 degree is root 3 over 2 and everything over 2. It's going to be 1 minus root 3 over 4 and then take square root. Should be 2. Think of 1 right here is 2 over 2. So 2 minus root 3 over 2 and not over 2 is over 4 and then take square root. Sine 15 degree. Okay? let's try another one. Look for a trig identity then. Find any example that's a little bit more complicated. I don't want to try something too easy. Okay, not hard, but not too easy then. I couldn't find anything hard enough, so try something medium. Okay, I'm looking at this one. Show that sine square of x over 2 equal to tangent x minus sine x over 2 tangent x. Tangent x minus sine x over 2 tangent x. Alright, so obviously you guys see that tan sine of a half angle right here, x over 2, right? And on the right hand side is all whole angle, x, left hand side is half of it, x over 2. So that makes us think of what? The formula for half angle or double angle is the same thing. So if I think of the half angle identity, I would look for sine of x over 2. And we know that sine of x over 2 is 1 minus square root. Square root of 1 minus, let's say backward, 1 minus cosine of x and over 2. Okay. So square up both sides, and by the way, this is what you guys usually see when you get to cut one. They write it this way: sine A is equal to 1 minus cosine of 2A over 2. This is square. Okay, easier for you guys to remember. And then cosine square of A is equal to 1 plus cosine of 2A over 2. This is the same thing as that version when you take square root. And this, don't forget the plus or minus, your quadrant and the angle. But if you square up both sides, you come from here to here, and think of x over 2 is A, and x is going to be 2A. And I glad that those two is more popular. Yeah. Alright, I don't feel confident with the radical. I don't feel convenient with radical. But anyway, it's the same. Okay? So plug it in here, sine square. I'm going to square up, so get rid of the radical. So really, my left hand side will be 1 minus cosine x over 2. 1 minus cosine x over 2. Right now, all the angle back to the whole angle of x, no more half angle. And how do I prove that this one is equal to tangent of x minus sine x over 2 tangent of x? Another little technique that you guys use a lot of, I think I mentioned last time, is what you try to bring everything back to sine and cosine. Okay? Because sine and cosine is two fundamental trig functions. So I can convert tangent into sine and cosine. The left hand side is okay. You know the tangent is sine x over cosine x minus sine x all over 2 times sine x over cosine x. Okay. Now simplify this fraction by multiplying both the top and the bottom by cosine. The purpose is to get rid of the denominator. Times cosine of x here, times cosine of x here, and you have the answer. This is going to be sine x minus sine x cosine of x over 2 sine x. Now cancel out the sine x on the top and the bottom. You got 1 minus cosine x over 2, which is the left hand side. Okay? So I'll just show you, I think in this type of problem is considered about medium in terms of the level of difficulty. Not too hard, not too easy, but again, you need to get through this smoothly. Spend some time practicing, alright? You may get stuck somewhere in the middle and try to find formula for it, and if we got stuck so long, don't hesitate to email me, ask me, and I'll find out how to solve the problem and Now let's move on to the next section, the last section. Oh, actually this is the last section already. So let me spend a couple more minutes on examples. Let me find a couple more. Okay. I'm looking at problem right here. Sine 2x over 2 sine x. Oh, this is like double angle formula. Show that equal to cosine squared of x over 2, cosine squared of x over 2, minus sine squared of x over 2. Oh boy. So in here I got double angle, I got the whole angle, I got half angle. So the first thing that you guys should think of first thing I would think of is try to bring everything back to the whole angle formula. Okay, so all the time of sine and cosine of x, not 2x, not x over 2 anymore. And now I'm looking for the identity for sine of 2x. I know that sine of 2x is 2 times sine x, cosine x. And that's over 2 times of sine x. We see that there's something to help us cancel out. And we know that we're on a good track, okay, on the right track. And what about cosine of x over 2? Cosine square of x over 2. And again, the formula that we have is what? Cosine of x over 2 is equal to plus or minus square root of 1 plus cosine x over 2, I think. Yeah? Let me double check. You see why I have to double check? Because in my mind, this is what I have. Because I teach calculus. So cosine of a is square. It's 1 plus cosine of 2a over 2. This is what I have in mind. So let's write it up of the book version. Take square root of both sides, and instead of think of the whole angle, the double angle right here, think of x over 2, and then x right there. Okay? And same thing. Sine of 2x, x over 2 is plus or minus square root of 1 minus cosine of x over 2. Now, look in here, square, so I have this is 1 plus cosine of x over 2, and then subtract, this is 1 minus cosine of x over 2. Okay, so with just one problem, we are using the 3 different trig identities. Alright, now let's simplify. This is what? Oh, did I erase something? Yeah, I erased something here. 2 sine x, cosine x over 2 sine x, and then equal to 1 plus cosine x over 2 subtract 1 minus cosine x over 2. You guys see what? After just the first line from the left hand side, we convert the double angle 2x to the original angle x. On the right hand side, we convert from half angle x over 2 to the whole angle x. And now simplify this, cancel out 2 sine x, cancel out with 2 sine x. We have just cosine x left. On the left hand side, what do I have? 1 plus cosine x minus of 1 minus cosine x over 2. You guys see we need to put the 1 minus cosine x in parentheses. Very important, okay? Because later on you have to distribute a negative sign into the 2 terms. And now distribute, you got, let me cheat on them. 1 here and then add in here. Okay, that 1 cancel out the 1. This is 2 cosine x over 2. Cancel out the 2. You have the answer. Okay, so I give you all the formulas that you need for your sections and show you a couple examples. Of course, different example gonna have a different approach, but the main idea is pretty much similar. You guys try look at the problem and try to figure out which formula should you use. And it's okay if you choose the wrong formula.